If you have an extensive form game, then just knowing the information sets and the actions available to the players at each information set, you can write down what the strategy sets are for the two players, or for every single player, you'd be able to do that. But the extensive form tells us a little bit more than just what the strategies are. We also have the payoffs that they get from each combination of the strategies. So what we can do is to write these down as a function of the strategies. So let's suppose we had player 1 playing strategy H and player 2 playing strategy H prime. Well, if they do that, we've got ourselves a strategy profile. And we can write down then, well, where do we end up? Well, player 1 is going to play H. Player 2 is going to play H prime. So we follow this branch of the tree, we follow this branch of the tree, until we end up here. So we can say that the utility for player 1 is going to be 1 from this profile of strategies. And the utility of player 2 from this strategy profile is also 1. We take another example. Write down the profile, let's say L and H L prime. That's another strategy profile. So that has us following this branch, and player 2 plays this strategy. So we go here, and the payoffs are a half. So in general, what we can do is write down a function for each player, ui. So we call this a payoff function. It's a function from strategy profiles to real numbers. Once you have a strategy set for each player, so if you have S1 through Sn, and you have these payoff functions u1 through un, each of which maps the set of all strategy profiles to a real number, then you've really captured everything that's in all the information contained in the extensive form is summarized in these two things. So all you really need to describe a game is the set of strategies for each player, and given a profile of strategies, what the payoff is for each player, then you've got a full description of the game. And we call that a normal form. So these describe all the information in the game. And so this is called a normal form. So we've kind of taken away the tree structure, and we're just summarizing the strategies using these vectors. And we summarize the payoffs as these functions. And a common way to represent these normal form games is as a table. And it's particularly easy when you have only two players. So let's look at this example. What you do is you write down the rows correspond to player 1. So player 1 has two different strategies. Player 2, so this is player 1. Player 2 has four different strategies. Remember they're H prime, H L prime, L H prime, L L prime. So now we can write down a table and we can just fill in the payoffs to the two players. The convention is to write the payoff of the role player or player 1 first. So player 1 goes first, and then player 2. So if they play H prime, player 1 gets a payoff of 1, player 2 gets a payoff of 1. If they play H and then HL prime, so we have H and HL prime, then the payoff is going to be, again, 1 and 1, because we're going to end up here. If player 1 plays H, player 2 plays LH prime, then the payoff is going to be 0 and 2. H and LL prime is again 0, 2. You can proceed this way to fill in the rest of the table. So you have another here for L when player 1 plays L, and then you write down all the payoffs for the different strategies that player 2 might play, and then you end up with this table. So these two representations, the tree that we had earlier and this table, are equivalent representations of the same game. The earlier representation with the tree is called the extensive form representation. This is called the normal form representation. Chapter 3 of the book has a whole bunch of examples of normal form games, so I'd encourage you to have a look at that. So take a look at the examples in chapter 3. I showed you how to take an extensive form, so something like this, and turn it into a normal form. So you might wonder, well, if you had a normal form, is there an obvious way to turn it back into an extensive form? And this example should show you that it's not quite that straightforward. There's a unique normal form up to renaming the strategies. There's a unique normal form for every extensive form game. So if I take this extensive form, I'm going to get this normal form. But if you start with this normal form game, you could end up with either of these extensive forms, and they're both extensive forms that correspond to the same normal form. So in other words, there's always a unique normal form that represents the equivalent game of an extensive form, but the converse is not necessarily true. And when it comes to analyzing games where players always play at the same time, so they decide on their strategy simultaneously, there's no loss in studying only normal form games. But when we want to study more dynamic settings where players are moving sequentially and making decisions sequentially, having observed what other players did, then you really are going to want to use an extensive form game to conduct your analysis.